Thank you for allowing me the opportunity to come and speak to you today. I see we special ordered our Seattle weather specific for you, so I hope you enjoy it. Nice drizzly fog that we typically see in the fall, but occasionally happens there at the beginning of our summer months as well. So I'm Kenny Swope, and I tend to wander around a lot, so I apologize in advance for that. But I am at the Boeing company. I am in the commercial airplanes engineering organization, and like so many people, I have 3 jobs. But the ones that I think really factor in today here is what I do around what we call business architecture. So at the business unit level and at the enterprise level, I lead a team that is developing our architecture. And you think about that, our processes, tools, data structures, and how we organize the corporation. And I'll get into a little bit of that in my remarks, but the other thing I do when I'm not doing that is interact a lot with industry standards. So I'm a chair of an ISO committee, ISO TC184, SC4 industrial data, and we have some great collaborations going on with the ISO committee around PDF, and I'll talk a little bit about that as well. But before we get started, maybe a few comments about Boeing. So these are some of the things that we do at Boeing, and it's always really kind of good to look at it because the Boeing company has got an incredible portfolio of product. On the left-hand side, we talk about connecting. So in our commercial airplanes division, we deliver a full suite of commercial aircraft product support and services. In our Boeing Defense and Space, protecting, this is the products and services for the warfighter. Exploration, we've got a very active program in our space and satellite launch divisions. And then we have a huge footprint in community service that we're really quite proud of. And so this is, if you will, the Boeing company on a page. Just a little bit of history about Boeing. We are a collection of companies actually that mirrors the history of flight, and quite proud of this heritage starting in 1916. And you can see across the bottom here some of the companies that joined the Boeing family over the years, going back to the earliest days of flight here in Seattle, of course, starting in the Seattle area, but now really with worldwide operations in aerospace. Just a little bit here, our commercial airplanes, of which our Puget Sound is our center, if you will, of operations. Our headquarters for commercial aircraft are here in the Puget Sound. We have a bank, the Boeing Capital Corporation, located in our Washington, D.C. offices, obviously with the kinds of products that we sell. Financing them is a huge challenge, and so we offer those services to our customers. Our Defense, Space, and Security is one organization that provides those services, and they're out of Washington, D.C. And then a new unit, it's actually about a year old now, Global Services, and this is a huge opportunity for us as a company to move in the revenue-generating market of support and services using not only our products, but also new options and new acquisitions in our corporate portfolio to provide really that end-to-end service offering for our customers. And to kind of connect it to today, right, PDF fits in every last one of these segments in some fashion. And we'll talk a little bit more about that in a minute. Just a little bit more about us. We are a global company. We have operations in 150 countries, 100 billion in revenue, with aspirations for much more than that. 20,000 contracts. Interesting little data point there. 20,000 contracts, suppliers and partners globally. PDF really factors heavily in those kinds of relationships and how those operate. And I'll talk a little bit more about that in a moment. 150,000 employees worldwide, plus or minus, and $284 million in direct community involvement. And I have to say, I'm really inspired and appreciate what Boeing does for our community, and I really believe that every corporation should have an aspiration like Boeing provides for this. Just a little bit about our footprint. Some people might think that Boeing, right, is a U.S. company, and it is. But we have operations worldwide. We have subsidiaries in all of the developed countries in the world. Support and service centers, of course, next to practically every airport on the world, and major facilities for service and support. For example, in Asia, in Europe, subsidiary, new relationship with Embraer in Brazil, and new relationships with companies in Europe. So changing gears a little bit, so that was kind of the company. One of the things that I do, I'm part of the engineering department, and so in the engineering department, of course, we talk about our product design. And the Boeing company and its product tends to have a very long lifespan. We have product 707s that are still flying today, and those were designed literally on paper. You can see a gentleman there over a drawing board working on a print. Our vaults still contain Mylars that are considered authoritative. B-52, by the way, interesting little tidbit for Air Force bombers, the number represents the year that the drawings, or if you will, the design, was approved by the Department of Defense. So B-52, which is still flying today, and we're performing a re-engine on that program, is an airframe that dates back to the 50s. Our commercial aircraft aren't around that long, but they too have their own sort of challenge. If you look at 1990 to 2005, where we have the beginnings of digital, we called it computer-aided design, computer-aided manufacturing, and progressed that incrementally through 2005 until now. And really, it's about how we enable our engineering teams and our manufacturing teams in the supply chain with the latest in automation, taking advantage of digital design techniques. What's curious about this is that this entire page is still in existence today as a company. We're required to maintain that going forward. We have many regulatory requirements. Regulatory requirements drive us to maintain what we call a type design, and that type design has to exist for the life of the aircraft plus a certain number of years. And these all of these technologies for us have to stay in place in order to provide that kind of service. So as we look to the future, one of the things that Boeing has embarked upon is our chairman has initiated what he's called Project Accelerate in our second century. In 2016, Boeing celebrated 100 years, which is a pretty notable achievement for any company. But not standing on our laurels, we recognize that to be competitive in the second century, we have to do things substantially different than what got us to our conclusion of our first century. And one of those is how are we going to take full advantage of digitalization and the use of the computer, not only in automating tasks that are inside a specific work group, but automating the entire ecosystem and enabling the digital data that lives in these systems, not only for the productivity improvement that existed at the department level, but leveraging that for really a corporate advantage. So this is what we call our Second Century Enterprise Systems Initiative, and you can see many elements of it that taken together talk about the overall corporate optimization strategy that we're embarking upon. And really, it's anchored by what you see in the center, which is what we're calling our digital thread. Thank you for that. I can see the slides a little bit better. Our digital thread, which is a series of foundational applications, PLM, ERP, and MOS. So these are product lifecycle management if you're in the engineering department, manufacturing resource or enterprise resource planning if you're in the supply chain and finance departments. MOM is manufacturing operations, and this is, if you're in our factory, how you execute factory operations and provide visibility for production. And then we have a collection of applications that surround that, including our HR systems, to some extent our financial systems. And really the point behind this is to completely rethink how work happens at the Boeing company. Coupled with, as you saw in the previous chart, right, we have a rich heritage of commercial experience and military experience and space experience and service and support experiences. And what we're really after is trying to leverage the capabilities of all of those in a thing we call One Boeing. And the idea is that by using these applications and using the revised work processes around this, we can achieve One Boeing scale and One Boeing productivity in all of these domain spaces. This is an effort that's underway right now, and so we're in the early phases of it. As with any large transformation project, it will take a bit of time, but we're really excited about the opportunity that it provides. The other thing that it takes advantage of are some advanced concepts like blockchain, cloud, analytics, and IoT. All of these factor into our architecture about enabling access to the data. And for us, really, it's about how we unlock that data, because at the end of the day, that data is a corporate asset that we expect to leverage. A couple of examples of how we are rethinking, if you will, our approach to the kind of work we do. This one comes from engineering, and if you're familiar with the engineering space, you've probably heard about the systems engineering V. This is an artifact, if you will, that comes from really a rich history of systems engineering approach to how you take a requirement, in this case a regulatory requirement, and demonstrate all the way through in a systematic approach the fact that you verified that requirement and you validated it back. For us in a regulated industry, it's very important. We have to prove these things to regulatory authorities, and we have to provide the evidence of that. And so the systems engineering discipline itself has evolved what I'll call the bottom half. We call this the diamond. The bottom half of this to have, if you will, physical artifacts or analysis artifacts that prove our design all the way through, from the initial requirement definition all the way through to the build and to the ultimate testing of that to come back to the requirement. With the interesting thing is that for systems engineers, that all emerged in an era of paper. So a paper process for documenting a requirement, a paper process for taking that requirement and doing an allocation exercise, a paper process for doing the design, a paper process for doing the manufacturing, a paper process for testing. So the actual thought process, if you will, the mental model that goes into engineering is based on paper. And it still is today. So the question is, how do we change our culture? Because with automation comes new ways of thinking, new ways of solving these engineering problems that maybe we would have taken a different approach in the past. But we can get locked into our own thinking of how we've done it in the past to actually take advantage of digital technologies and the linking of data in ways that we weren't able to do before. So the top half of this diamond is really to speak to that. And that is, for everything that exists in the physical world, there is a virtual representation of it. And we use a lot of these things today. Don't get me wrong. We have computers in the hands of every employee of the Boeing company, right? The question is not whether or not we can put computers in the hands of Boeing employees. It's can we make them, right, unlock new value, new productivity, and new efficiencies with the access to the data that they use to do their job every day. And so rethinking the top level of this process with, if you will, the virtual representation of the physical world. So you think about requirements, the business model, the model-based definition. This is the design of the aircraft or the design of the system, the seamless integration of requirements and allocations, the feedback of testing data, and the performance of simulation. So probably one of the biggest levers here in terms of rethinking how engineering design is done is the role that simulation plays in performing the engineering process itself. In addition to that, the manufacturing and how manufacturing is done also relies heavily on simulation. And if you've ever done anything with simulation, you know that details matter and how the data is connected across domains is very important. So this is an opportunity, what we call here in the center as our digital thread, is what is the logical connection of this data to perform that end-to-end kind of connectivity and simulation analysis that allows us to accelerate the physical world. And that's really the point. We want to accelerate, right, the physical world and bring product to market faster. Another example that we talk about is in the factory. So in this case, comes from a manufacturing context, and really there's a lot of excitement around this when we think about what's going on in industry around Industry 4.0, smart manufacturing. You put the word smart in front of almost anything, and suddenly you have a new topic to talk about, which is fun. I always love those. But you know, the factory actually has a really rich set of use cases for how we take advantage of data, and some of these graphics indicate some of the things that we're doing today as part of our second century endeavors. In the upper left, this is an evaluation, if you will, using a digital representation of product for mechanics to assess whether or not they can assemble the aircraft. In the lower left, we have robotic automated driving machines for factory deployments. We have in the middle here, this is a composite tail section, the 787, and automated equipment that lay up the tape and perform automated inspection in real time of that product. We have down there automated fastening. So in the center bottom section here, this is an automated fastening system that not only drills and fills the fasteners that hold sections together, but it inspects itself. It provides the feedback data using IoT technologies about how it's working and any quality-related issues. Upper right is an architectural configuration, if you will, of how this all fits against an industry standard context. So one of the key points here is that it's not enough to have the data and know where it is. You have to actually be able to interact with it. And strategically, when you are dealing with a lot of applications that need to interoperate, operating in those bespoke formats of the vendor applications usually doesn't work too well. You end up with a lot of custom interfaces. You end up with special procedures to deal with the data. And so what we expect to do here is use industry standards, if you will, as our framework for interacting with the data. So at every point in our architecture where we need to see the data, it's in an industry standard format that's already been agreed to, right, as an industry concern, and is stable for the long term. Again, back to that point that our product's in service for a very long time. And then the lower right is our 3D visualization and simulation mock-up of a factory operation. These are all great examples, actually, of things that we're doing today, but we intend to leverage more by access to more and more data sets, richer sets of information to operate more efficient factory operations. Another area that we're rapidly and aggressively moving into is machine learning, AI, and analytics. So we have a unit called Boeing Analytics that really brings to bear the approach to big data. This is both an internal offering as well as a revenue offering external, and its target is really how do we take advantage of not only our data sets, of which we have quite a bit, but also data sets of, for example, our service and support organization. So when we enter into a support contract with an aircraft company, how are we enabling them with revenue opportunities about how the aircraft is performing in service, predictive maintenance ideas, and alternative revenue streams for how to use that data. So now turning attention to a little bit closer to what I deal with in the engineering department, we have a rich history of delivering model-based definitions. So one of the use cases that I'd like to showcase here for you this morning is our use of PDF and model-based definition. So several of our aircraft programs, you can see some of them listed there, we publish the engineering design as an authoritative reference. In other words, this is a build-to specification to our supply chain for these aircraft and for these military products. We have a system we call REDARS, which is our reference repository that we use to distribute the supply chain. It has about 71 million PDF documents under curation in that repository today. Of course, that doesn't represent the totality of PDF documents in Boeing Company. This just represents the set that comprises our design. And what we do with that is we use that to distribute, if you will, our engineering design to the supply chain and to ourselves internally as well. And it consists of the manufacturing specification, the requirements, the testing specifications, any kind of formal communication that we need to build our product against. And it includes, in many cases, a 3D model. So we use the PDF document format coupled with 3D model distribution. And of those, we have about 3 million of those kinds of documents in our repository. With this, we've extended, if you will, the use case of how we communicate with humans to not just talk about something on an electronic document, if you will, but advancing to now I have digital content inside that PDF structure that I'm able to rotate, I'm able to interrogate, I'm able to annotate, and do extended operations with that adds my own intelligence to the data set going forward, but yet still have that connection back to an authority reference that I release to the supply chain. So we're really pushing the boundaries of taking advantage of all of these capabilities with 3D publication. We get about 200,000 views a month, so maybe that's not a big number to PDF, big systems, but I think it demonstrates for us a pretty consistent utilization and consumption pattern for this. And on one program, we publish about 40,000 technical data packages. So a little bit of industry speak here. The technical data package is a DoD concept, but it's also used in our commercial spaces as well, where when we deliver on a contract, all of the product definition, the requirements, the specifications, the materials, any kind of contractual information is delivered, if you will, as a container to our client, usually the DoD. We use PDF to do a lot of that, and we get about 16,000 downloads per month out of our repository. So, for us, just using this one use case, obviously there's value in having a distribution channel that continues to support our industry stakeholders with the PDF content. But this is not the only one. I talked a little bit about some of these use cases that we talk about. Mill Standard 31000, which we may have talked about a little bit here. Right? DoD is examining that and looking at alternatives and what a new revision to that standard would look like. Obviously, we're very interested in that. Co-production partners. So we have many programs where we have design partners. We collaborate. We collaborate on the design. The 787 program is a perfect example of one, where we have companies that don't just build parts for us. Right? They contribute to the design and they collaborate in the design towards the final solution. Of course, delivery access to our customers. We maintain a repository of documentation and technical publications. When you get an aircraft and it's delivered to you in the old days, we would have loaded the hold with all of the paper documentation that goes with that. It's usually a couple of pallets. The maintenance manuals, and in your car, you've got anybody ever read their maintenance manual in their car? Anybody have a maintenance manual in their car anymore? So today, we deliver all of that. We deliver all of that digitally. Interestingly enough, we also deliver the training, right, and any kind of service and support that comes from that digitally as well. And then finally, delivery access to our suppliers and shop floor. I talked a little bit about this in some of our examples from the manufacturing space. The shop floor use case is a very powerful one. We have on-demand delivery of many documents and content. We also have delivery of the 3D representation of that content as well. So these are all really important use cases from an engineering perspective, from a manufacturing perspective that we looked at PDF to help us with. But we also, PDF isn't the only game in town when we talk about standards. So this is a chart that we like to talk about because PDF has to operate, if you will, in an ecosystem of standards that we use to enable, if you will, the federation of this data. This radar chart consists of really what we consider to be our top priority standards for this space. And always washed out on that one, but it's a red, yellow, green chart, if you can see it there on your screen. And these standards, if you will, span the engineering domain, the manufacturing domain, the supply chain domain, and consist of things like STEP AP 242, so ISO 10303, which is a standard that I know a lot about, is used for our product design and how our product design is distributed to the supply chain. But we also have standards, for example, in LOTAR, these NAS standards. These relate to the long-term, right, archive and retrieval of our design data and how we intend to keep those for the long term, which, by the way, PDF is a piece of that. We have PDF, and we note also that we not only just PDF, but we have PDF A and E, and I know that the ISO committee has recently adjusted that, and we have now the PDF standard as well, but the engineering aspect of that, if you will, the digital content is very important to us. And we have partnerships between the two ISO committees on doing some joint work to further that. But we also have other spaces like systems engineering, so SysML 2.0. We've got some supply chain support with S1000D, Spec 2000, and then some work here in architecture. So some of these spaces up here, like IDEF, are more like architecture spaces. The point behind this chart is that I think for companies, the key message is you have to declare what's important to you. And so when we talk about digitalization and we talk about taking advantage of the transformation that things like our second century enterprise systems offer to us, it's not enough just to talk about the apps you're going to buy and put on your computers in your company, but you also have to talk about your strategic approach to how you're going to manage data. And that's just as important as the apps you buy as well. These standards form a critical component of which PDF, right, is a key part for that. So I will conclude by coming back to the chart that I started with, which is about our company and what we do, about connecting the flying public and protecting the interests of nations, providing exciting opportunities to space and beyond, and being a voice in our community that really advocates for the local objectives of the organization. So with that, I don't have any more remarks. I think we have a little bit of time if there are questions. I'm certainly willing to take questions at this point. I think we have a microphone up here. I think it might work. Yeah. questions?
I mean, we yesterday. Yesterday had a discussion here about things that matter in PDF, like accessibility, tagging structure, or maybe structure and information inside of the PDF file. So there was a big discussion that actually PDF is not as always as yet another PDF. So there are quality differences between one PDF and the other, because one might be richer with information than the other. Is this something you think about in your processes, or it's just PDF is PDF?
PDF is PDF. I heard a little bit about this discussion from yesterday. Not all PDF are created equal. I mean, I think that's a pretty obvious statement, especially the experts here in the room. The structure of the PDF content is actually very important to us. One of the things that, if I just go back to the 3D example, there are use cases that I've seen where companies have taken a 3D package and literally dropped it in as a container inside a PDF document and shipped it out and said, there you go. Right? And that requires not just the PDF itself, but also the interpreting application for the content that's inside that. And oh, by the way, it goes around all the security protocols that PDF has worked so hard to put into the basic frame of the document in the first place. That, to me, is not a solution that takes advantage of the technology that's available. But in order to use the technology that's available, we've got to agree on its structures. And I'll take a use case out of our engineering design. If I take PRC and I create a PRC file of the engineering design, and I give you the ability to rotate that data and look at that product from multiple different views, I also want to be able to extract the manufacturing requirements out of that design data set. And I want that to be in a PDF document, because I want them to be able to consume it directly. If they have to go into the file and then read the 3D and then type it into something else, I've failed. It's actually not leveraging the use capability of the format. It's not leveraging the capability of our data. So that's an excellent example for me that it's two parts, right? You have to have a frame of the packaging solution to be able to accept the structure. Then you have to have agreement on the structure itself. And oftentimes, that's where the difficult part comes in. In my case, we have collaborations with Airbus, believe it or not, where we talk about things like, can we get to an industry agreed to representation of a bill of material? So if you think about a product design, it's got part numbers, and it's got a structure and hierarchy of these part numbers and how they relate to each other. Well, as it turns out, in the aerospace industry, we all do it differently. So if I'm a supplier, I saw Crane here today, they could probably resonate with this idea. If I'm a supplier and I'm building parts for Airbus and I'm building parts for Boeing, I actually have two different solutions on how I handle just the bill of material. And they probably both sent me a PDF document to communicate with me. So can we get to an agreement of the structure of the data? That's a huge industry challenge. But I think both are required in order to truly take advantage of the standard, federation, and the technology. It's a great question. Thanks. Yeah.
Based on the model-based design, very happy to see there's some slides there. There's Boeing is leading this. We are trying to catch up or be in the same level of Boeing's expectations. So on the model-based design, the annotations and the that you mentioned, there's PMI, product manufacturing information.
Yeah.
When do you expect exactly that slide?
This one, right?
Yeah, and also the circular one where you have all these different formats. When do you expect? We are under the guidance that the NMA, Next Market Aircraft 797. We need model-based definition and model-based system engineering, as you mentioned. What is the time frame approximately that we have to make sure we are in line with Boeing's delivery? That's one question. The other one, I do see JT. Does the yellow circle mean is that more important or less important? The code green is the more standard formats you accept? Because we could deliver as JTs or PDFs, we want to standardize in one format.
Okay. All right, great. I'll start with the easy one. I can't speak about timelines. So in our, so what I was commenting about was some of our new product development where we're incorporating and taking advantage of some of these features. I don't have any specific timelines for you here today that I can share, but other than to say that we're looking at it, and I think that we talk about our strategy, it factors heavily into our strategy going forward, not just for that program, but for multiple programs. With respect to JT, the way to read this chart, by the way, if you can see the words, it's a tracking, it's a candidate, and it's an adopted targeting, if you will. And so JT is in that candidate space. As you can imagine with the Boeing company, we fortunately or unfortunately probably own at least one copy of every software ever written on the planet. We have 4,000 line items of software entries in our internal registry of software applications. And in this case, we have a rich heritage of our defense space and space programs, Siemens as a CAD solution. So obviously we have to respect that, and JT, right, as a component of that. As an industry standard going forward, we continue to examine that. You can see here, though, that we have STEP and 10303 really already in the adopted space, and we'll probably likely continue that strategy. But we do recognize the value of JT and continue to look at that format. Yes.
So great talk. I wanted to ask a question rising from yesterday. We were speaking a lot yesterday about user education. Obviously, Boeing has you sort of 150,000 employees yourself, and then when you include your supply chain up and down and all the other parts of the business, how do you think we're going on educating people beyond the technical engineers, understanding what PDF brings, what its capabilities are? Have you got any sort of feedback for us as PDF people about how we can do a better job? Because obviously pushing 3D PDF has been a challenge for you. Maybe we'll talk a little bit about that as well.
Okay. Yeah, great question. So I'd say it's a target-rich environment. I think there's lots of opportunity here around, I'll say, the perception of PDF. So, matter of fact, I was in an ISO meeting just last week where Leonard had come and talked to us about machine-readable standards and the opportunities for ISO to publish standards in a different way. And it was a perfect example of the perception that PDF has, which is, it's an electronic document. And so I think that there are some huge challenges ahead in terms of being able to re-message what PDF's capabilities actually are, because frankly, I don't think most people know what PDF's capabilities are. My Microsoft Office suite has a print to PDF button that, quite frankly, most people, they probably hit that button. But there's much more. And I think when we talk about sort of the branding and communication of the capabilities of PDF, there's certainly things that association and others can do to promote that. And really, I think you have to attack it from a cultural perspective. One of the things that we've learned really quite the hard way is digitalization is not putting technology in the hands of users. Digitalization is about seriously examining the culture of your organization and deliberately transforming it to take advantage of what data has to offer in this day and age. And I think if you come at it from that perspective, that it's really a transformation and how can PDF take advantage of the transformation and help enable the transformation, would be a very, very powerful message. But great question. I think I've hit my time for this morning, so I want to thank everybody for listening. And if you have any further questions, I'll be around for a little while. And have a great day at the conference.